This problem is asking you to compare two different tensions at angle scenarios. The first one is the one that we just did. So you have T2 upwards at an angle of 37 degrees and then T1 completely horizontal. And then you have, in the second scenario, both are angled. Now in the first situation, there was only one upward force to combat the downward force of gravity, which meant that the upward component of the tension force was directly equal to the gravitational force. In this situation, which is the second situation, you don't just have one upward force, you have two. And those two upward forces now mean that they are not each going to equal gravity. Together, they're going to equal gravity. So the y component of T2 in scenario 2 is less than the y component of T2 in scenario 1. That means that the total hypotenuse has the ability to be smaller if necessary. Now in this situation, the x components, the previous problem, we had one wire that was completely x, so that had to directly equal the x component of the angled wire. This situation, we have two angled wires, so that means each of their x components has to be equal. So we need to set up relationships for both. So when we make our triangles, we have that T1x is equal to T1 multiplied by the cosine of the angle. The same way that T2x is equal to T2 multiplied by the cosine of that angle. Now because of equilibrium, those two things have to cancel each other out, which means we can establish a relationship between T1 and T2, which we can then use in our y values to see which one supports more. So cosine of 53 is going to give us a value of 0.601. The cosine of 37 is going to give us a value of 0.799. So if T1 cosine theta equals T2 cosine theta, that means that T1 by itself is equal to T2 cosine theta divided by the cosine of T1's angle, which is 1.33. So that means that T1 is equal to 1.33 T2. We can take that relationship and plug it into the y's. So now T1y plus T2y equals the force of gravity. So that would be T1 multiplied by the sine of theta plus T2 multiplied by the sine of theta equal to gravity. Since we have this relationship for T1 and T2, we can plug it in so that anywhere that we see a T1, we can change it now to a T2. That gives us only one variable, which we can then solve for. And since the problem was just looking for T2, we don't care about T1 at this point. So when we go through that whole solution, we can see that by doing this, we end up with very different values of T2. So in which situation is the one larger? Well, by looking at the fact that when there is more x, there is less y in order to support the actual object. So if we have a tinier value for y, that means that all that sideways support just immediately goes away, which puts more stress on the vertical support in order to support the weight. So which one is T2 larger? And how do you know moving forward? We get down to this value and we see that we have a T2 of 2.945 newtons. So just using this relationship, it makes sense because we already have established that when they have shared y components, the actual tension has to be less because it doesn't have to support as much. So basically what that tells you is that if there's only y, the tension is going to be larger because all of that weight has to be supported by one single wire, which then directly increases that tension. And then if we have a larger x value, and I say x because I just mean horizontal, if that distance that it has to traverse is greater, that means it's putting more strain on the vertical, so that means that the tension is also larger. So if you think about it in triangles, big x component, you can have a large hypotenuse. Big y component, you can have a large hypotenuse. So as long as one of the sides is larger, that's what happens. So the more spread out your wires are, the greater the tension. Then you'll notice that in this situation, T2 is greater.